Okay guys, now let's get into mode of vibration of air column in pipe closed at one end, okay, and open at other end, and in case of pipe open at both the ends, and vibration in stretched string. Alright, and these are what we call as fundamental or first harmonic. These are what we call as first overtone, second harmonic, and these are what we call as third harmonic or second overtone. What we have got to keep in mind is the boundary condition. Boundary condition says that at open end, wave always forms antinode, whereas at close end, it forms node. Alright, so that's what you would find over here. At this place, we are finding antinode, open end, open end, open end, all anti-end, all antinode, closed end, closed end, closed end, all nodes. Here we have got both open ends, so antinode, antinode. Here in case of string, since it is tied over here, so it is node. So when it is tied over here, node, and again it is tied over here, it is node. Alright, now let's understand the fundamental or first harmonic state. Now in case of first harmonic state, one thing I have got to make it very clear that the length of pipes chosen and length of string chosen are same, and it is L. Okay, alright, now in this case we say this. So as per rule, we get in case of first harmonic or fundamental, what we get is this. Alright, now if we talk about this to be first harmonic or fundamental, then in terms of wavelength, obviously this is lambda by 4. Alright, so L is equal to lambda by 4. Let's check in this case. In this case, it is lambda by 4, lambda by 4, lambda by 4. So it is 3 lambda by 4. Okay, in this case, it is lambda by 4, 1, 2, 3, 4, and 5. So L is 5 lambda by 4. So in this case, it is lambda by 4. In this case, it is 3 lambda by 4. And in this case, it is 5 lambda by 4. So these are the situations here. Okay, now before we get into pipe open at both the ends, let's understand this also. Some basic formulae. Now velocity of transverse wave on string V is equal to root of T over M, where T is tension as clamped between rigid support. So if suppose this is the wire which we have plucked, okay, this is the wire which is stretched in between rigid support, so it has tension. Alright, so it's that tension, and this small m is linear density of string. What do I mean by linear density of string? Linear density of string means it is capital M over capital L. Now capital M is mass of string and L is length of string. Okay, now this is the formula which we have got to keep in mind. V is equal to velocity is equal to root of tension over mass per unit length. Now this thing we would be applying not only for string, we are going to apply this formula also for pipe closed at one end and pipe open at both the ends. Okay, having understood this, now let's proceed. Now we already have got a relationship of length and lambda. Okay, so let's start deriving formula for frequency for all of them, all three of these states. L is equal to lambda by 4, that we have already seen. So lambda is equal to 4 by, obviously you take 4 that side, and N is equal to, we know that V is equal to N lambda. Alright, so if we want to talk in terms of N, it would be equal to V over lambda, where lambda is wavelength, V is velocity. Okay, so N is equal to V by 4L. Why 4L? Because lambda is equal to 4L. So this becomes the formula for frequency for first harmonic. Okay, then when we go for second harmonic, we know lambda is equal to 4 by 3L, N is equal to V over lambda. So this becomes V over 4 by 3L. Now 4 by 3L means it is 3 into V by 4L. Alright, 3 goes up. Alright, 3 into V by 4L. N1, we call this as frequency 1. So N1 is equal to thrice this, 3N. Okay, let's check out this now. In case of third harmonic or second overtone, what we found is L is equal to 5 lambda by 4. So lambda would be 4L by 5. N is equal to V over lambda. And lambda just now we told it is 4L by 5. So that's what we substitute, 4L by 5. Now 5 goes up. So 5 into V upon 4L. Now this we know is N. Alright. So this becomes 5N. So what do we observe? We observe that in case of pipe closed at one end, fundamental or first harmonic is N. First overtone or second harmonic is 3N. And second overtone and third harmonic is 5N. Alright, so N1 is to N2 is to N3 is equal to 1 is to 3 is to 5. Now pth overtone is NP is equal to 2P plus 1. Now 2P plus 1, why? Because it's odd number, right? So 1, 3, 5. So odd number I already have told you, when 2P plus 1 is the formula used for getting odd numbers. Like if I substitute here 0, it would be 1. If I substitute here 1, 2 into 1 is 2, plus 1, 3. If I substitute 3, 3 2s are 6, plus 1, 7. So for getting, and so on and so forth. So getting odd number whenever we want, we can write it as NP is equal to 2P plus 1. Fine. So that's what is for pipe closed at one end.